We have 0.719 moles of KClO3, and we want to figure out how many moles of oxygen gas we're going to produce. So I'm just going to go ahead and write that up here. Let's see, 0.719 moles, and we are looking for moles of O2. So start with what you're given, 0.719 moles, and that is of KClO3. Don't forget that part, because when you write your conversion factor, we want to be able to cancel out moles of KClO3, and we want moles of O2. Now, the very first thing we should do is check to see if this equation's balanced, and we can tell it's not because I said balance the equation. So we're going to need to put a 3 in front of here to balance out my oxygen. We need a 2 in front of the KClO3, and then a 2 in front of the KCl. So my mole ratio between oxygen and KClO3 is then 3 to 2. So then we go ahead and open up our trusty calculator, and we have 0.719 times 3 divided by 2. And we get an answer of 1.0785. We want 3 significant figures there because the 0.719. So it's going to be 1.08. And that is going to be moles of O2 because moles of KCl has canceled. All right, next question. If you react 19.6 grams of aluminum with excess sulfuric acid, which means I don't have to worry about that, how many liters of hydrogen gas are we going to get at STP? So again, our equation's unbalanced. So to balance it out, we're going to have to put a 2 in front of the aluminum and a 3 in front of the H2SO4. And then we're going to need 6 hydrogen, so we're going to need a 3 in front of that H2. So starting with 19.6 grams of aluminum, rule number 1, if you're not at moles, find moles. And we know 1 mole of aluminum has a mass of 26.982. Once we're at moles of aluminum, we can go ahead and use our mole ratio. And the mole ratio we want is going to be 3 to 2. So for every 2 moles of aluminum that reacts, I should expect to produce 3 moles of hydrogen gas. And moles of aluminum cancel. We know that there are 22.4 liters of any gas at STP for every 1 mole of that gas, which this time we're talking about H2. And moles of H2 canceled. So let's go ahead and take our 19.6 times 3 times 22.4, and then we're going to divide that by 2, and then we also have to divide it by 26.982. We get a lot of decimals there, but we only need 3 significant digits, so 24.4. And that's going to be liters of H2. That's it.